warehouse development approach, basically you can say that we have few approaches. One is the top down approach, means the enterprise wide warehouse. Basically what you are trying to do here is for example, you have developed the, now you have an assignment to develop the business intelligence, right, balance scorecard. So you have identified your decision making needs, and now you are going to say, okay, where this information I'm going to get from. Some information may come from marketing, some information may come from HR, some information may come from finance. So basically you are designing the based on the overall mission and vision, you are designing the database or data warehouse for all the departments, which is already integrated, right? That is called the top down approach, but it's very expensive and it consumes a lot of time, because you have to talk to every single department, every single person, what are their requirements, what are, how they process the data, how much, and it takes a lot of resources, because you are developing the entire system into one, right? That's a bit expensive approach, and but it covers the whole business. That's the benefit of it. Even though it's time consuming, but it will give you the analysis for the entire organization in one system. And normally, because it's a huge system, it normally have a weekly or daily or monthly processing. The data mart approach, which is called the bottom up approach, means that we are designing the data mart data for each and every single department one by one. So we are developing the finance department first, then we will add on the data mart for sales, for customer, for HR, for market, for production, for inventory. But in this case, the properties that we are using, the format we are using, the way of collecting the data we are using is gonna be the same. It's not going to be different. So that is called the data march approach, bottom up approach. It's cheaper to implement, and it's specific to the business department, whichever you want to prioritize based on the money that you have, the capex that you have. You can spend and prioritize. You want to do first for the HR, or you want to do first for the customer, or you want to do first for supply chain, finance, whichever department you want to collect the data. Then you can go by the data mart approach, means you are going to collect the smaller information. And because it's a smaller in size compared to the enterprise wide warehouse, which is huge database, data mart are particularly smaller, and so they can be doing the daily reporting or hourly reporting, because they are smaller, and they are more simple in structure architecture, because they are smaller in sizes. So that are the two different data warehouse development approach. One is called the top down, and one is called the bottom up. So bottom up is cheaper, but it will take time to develop, and by the time the data is not developed, some department will be working on a manual database, right? Some will or maybe there may be some intermittent requirements that you may not be able to integrate. But for the enterprise wide warehouse, where you are developing the whole organization into one, is good, because it will give you the enterprise analysis. But the because its a size is quite huge, it will take a lot of time and the money to do it. Plus the because it's huge, it will not be able to give you hourly or daily processing. It will normally be able to give you only weekly or maybe nightly processing, because it's quite high in the space and the processing power. So it requires quite a bit of investment from the beginning. The cost in both approaches may be similar, because ultimately you are developing the entire system, but the time and resources in development is different. So there are the two different approaches, top down and bottom up. Okay. Now we will be going inside the data warehouse to see how the data representation model works. So basically there are many types of data relationship works. So one is called the entity relationship modeling. We will be just looking at it from a perspective of to make it easy. So where everything is related with the one. So here example, you have one-to-one relationship. You don't have multi-relationship, multi-relation with the multi-relationship modeling, right? So it's normally the sale. For example, sale is further divided into customer, into the store, into the period, into the products. So there are only four types, and then the product is again grouped into product type, customer into customer type or the region, and the store is again by the regions. So this is called the entity relationship, mostly one by one. These are pretty much simple to maintain but less flexible. For example, if you want to know the what type of product is bought by what type of customer, you have to go through the entire chain by looking at the customer and the sale and then the product and then the product type. But if there are multi-dimensional relationship, which is the and which is the another aspect of the modeling, which is called multi-dimensional, you will have those dimensions already built in. So it's the processing is much faster, but it's complex to develop because you may have to identify the relationships between the different type of data that you want to achieve. Entity relationship is simple, but it's a bit less efficient in a sense that it does not give you a lot of choices already made. If you want to identify the data, you may have to extract the customers by sales by customer, by product, and the customers. Any question? Okay. Then, so the entity relationship modeling basically is the entity. There are entities, attributes, and the relationship. So we will not go into the normalization because that's a bit of technical aspect. So we will not look at that. Then the other option for the entity relationship, as I was telling you, is the multi-dimensionality. Means you have multiple relationship with the multiple categories, multiple accesses. So here the ability to organize data by several dimensions. For example, sales by region, by product, by salesperson, or by time. So there are four different dimensions. So here the dimensions are multiple and you are able to organize the data into separate purposes. So which is different from the multiple organization. So in this type of data structure, you may have to identify the all the dimensions and the sub dimensions. For example, the dimensions are the product, the salesperson, the market segmentation, the business unit, geographical location, distribution channel, country, industry. Measures are usually also different, right? There can be money, sales volume, by head count, by inventory, by actual versus forecast, and by the time, daily, weekly, monthly, quarterly, yearly. So these are all the different dimensions, different measures, different times, and you may have to you can multiply that. The product sale by money, product sale by sales volume, product sale by head count, product sale by head count, by day, by week, by month, right? So there can be multiple choices. um, so you can have if you understand the permutation and combination, there are multiple combinations of data which is available. So it's highly flexible database, but it's also the complex to draw, right? It is not that easy. So that's the difficulty with this type of architecture. But this type of architecture is nowadays most common. Entity relationship modeling is not common anymore because it's very simple. It's too simple and less with less flexibility. So multiple dimensional is difficult to design, easy to use for result operations. Okay. So here is an example of the one dimension. So one we here in this example we are dropping the dimensions into multiple dimensions. So we are looking at the sales by state, right? And then the two dimension means we will look at the sales by year. And once you want to add more dimensions, three dimensions, you can say the sales by year by product. And then if you want to add more dimensions into it, then you will say sales by state, by year, by product, by salesperson, or by customer. So you can add as many as dimensions as you want to build into this modeling, but it's going to go more and more and more complex, but the data will be more finer and useful for your processing. Okay, so this is similar to what we were discussing earlier in the slicing and dicing. So you can dice the data as much as you want. Any question between these two models, entity relationship and multi-dimensional? Multi-dimensional is clear or not? Clear, right?
Got.
Okay,
yes, yeah.
Great. Then the another type of schema is called the star schema. Now, star schema is also the way to implement the multi-dimensional modeling. It's a way of multi-dimensional modeling. Basically, it's used to implement multi-dimensional analysis using the standard. So they are called RDBMS, standard relational database management system. So these are the star schema is a part of the RDMS, relational database management system, and it's the most commonly used in the data warehousing, right? There are multiple variations, but they have two main components. One is the fact table and one is the dimensional table. So the star schema or the multi-dimensional models basically have tables in their database, which is one is the fact, which is maybe the sales or purchase or the order or the shipment, the basic one, right? The fact. And then it has multiple dimensions that we have discussed: the product, the customers, the vendor, the store, the time, the currency, the quantity. Every dimension is there. There are multiple dimensions. So how does the star schema looks like? So fact table store the hard data. The real transaction is stored in the fact table, and dimension table store all the information about your different dimensions. So here you are going to collect a lot of information. For example, if I give you an example, you have a product, you have a customer to buy one pen. The customer has a name, the customer has a type, it has an address. The address also has state, country, pin code, and maybe the street number, has a phone number. So all that data will be captured into different dimensional tables along with the fact table. So that's the way of capturing the data. And fact table has many to one relationship with each of the dimension tables. So all the dimension tables are linked with each other through a foreign key, through a key, common key, which is available in every table. So I will give you a visual representation. Here you can see the color key is the foreign key, the primary key. For example, product, right? So product has a one dimension. So sales is the hard table, the sales, which is collected by the time key, by the store key, by the customer key, by the product key, dollar sales and unit sales. So basically you are giving, like, you can make it like a code, you know. So instead of saying the customer is Manish Gupta, you maybe have a name, you maybe have a code for me, which is like MG001. And now when you are recording the sale, you are saying that I sold $10 to MG001. Now MG001 has separate dimensions. They are linked. The two tables are linked by customer key, which is MG001. Now this has a name or a customer type, and it can have a location. So location can be another table which is coming into this coming into this customer as a location key, so that the location will also be separate by, like, my address, like state, country, pin code, street, telephone number, and other information. Maybe my market segment. So then it will have a name, customer type. Then customer type can be another table where you have a customer type key, and then you can identify the customer type. So you can add as many as dimensions to it, as many as information in this particular diagram. That's why it's very looks simple and very flexible, but it's difficult to build. Is it too complex?
It's slightly confusing with multidimensional.
It's the same thing. It's same as multidimensional. Is the schema, is the type of schema. So the modeling is two type. One is entity relationship and one is multidimensional. So entity relationship with means you have only one-to-one relationship. Multidimensional means you have multiple dimensions into the same criteria. So that's the model. And in multidimensional modeling, star schema is one type of multidimensional. So they are both the same thing.
Okay.
Okay.
But the many companies with the more the data can be generated, the more is the better.
Yeah. So
And
that's
then
why
choose the best way to.
correct. That's why the star schema database are more common nowadays. The multidimensional database are more common because they give much more flexibility and granularity to the data. You can have multiple ways of analyzing the data, and the table is because this link with the multiple keys is very easy to pull the information.
So, Mr. Manish, now we are